All right, so I'm live and I need to.
I'm gonna let you take it away.
Yeah, can I see the live chat directly from? I can see the.
You can see it from the YouTube.
Yeah, can I see? Yeah, I don't have to be in directly from. All right.
You can see it from the YouTube.
Yeah, I don't have to be directly from. All right, so yeah, it's going. I can
Oh,
hear your
Liam is on.
feedback. And yeah, what I want to do is get a window up of that. So, okay, there's William Finn. Let's see. So those of you that are watching, I see that there's 3 viewers here. We're not sure where where Jeff Stark is. We've finally started his link, and I have to stop scratching my head. I can see that in the feedback that I'm scratching my head a lot. That's good, Liam. Good that you're everywhere because it helps. We got the live streaming working, but we don't know where Jeff Stark is, and we're awaiting him to join. Right now we just don't know where he's at. We know I ran a little late on David Levy's talk, and it was an excellent presentation. And now I'm in here awaiting for live sky and astronomy trivia. So if you're here for live sky and astronomy trivia, well,
I just got an email from Jeff Stark.
Exactly,
and
Liam.
on his way.
Oh, go ahead, Jeff. What were you saying? Jeff, you went
I
back.
just got an email from Jeff Stark, and he is on his way. He couldn't get in because David Levy was going over, and you were the host, so he couldn't get in.
Yeah, so tell him to go ahead and join, and you may be letting him in. I don't know, but I'm going to kick off the trivia for those that are here, and we've got 8 viewers, and I am going to ask a simple question for all of the astronomy maniacs out there. What phase is the moon in or just passing right now? So anyone in the chat, if you know the answer to that question, the first one to type it is the winner. Even if you're a seasoned astronomer, you can answer the question. So we'll wait a while because there's a bit of a delay. And we'll see if anyone knows what phase, and I'll type it in. All right, Liam wins. He typed waxing gibbous. It is just past. Now for a bonus question, what phase did it just pass? And again, I'm supposed to not be scratching my head. I keep doing that. That's my habit. First quarter. All right. So congratulations, Liam. The prize you win is Best Avatar because I see Bernard 33 in your avatar. So congratulations, you won the prize. Now, let's do, okay, until Flint gets here, I'm just going to do a quick preview of Stellarium. So I'm sharing my screen. Here we go. We're sharing And not yet. Well, as soon as Stellarium fires up, there it goes. And we're going to do some trivia like this. Okay. On your screen, you see two items. You see the moon and you see Jupiter. But there's another planet in the night sky that you should be seeing. What planet should you be seeing right now? There's one more that is near the moon and near Jupiter. Let's see who gets it. Let's see if I can. Let's see. All right. Liam wins again. We're missing Saturn. And Tim, you get extra credit for not actually seeing Jupiter, the disk, but you could see the words that were on the screen, Jupiter. So that one doesn't count. So you come in second place for that one. So Liam is winning again. Okay, I gotta ask something that Liam doesn't win. Let's see, 14 viewers. While we're still waiting, feel free to chime into the chat, introduce yourself and where you're from. And I'm gonna make up another question from Stellarium to find out what's going on. Tim, I just read your chat. It wasn't quite dark enough to see the point of light. Well, I'm about to go fix that. So let me get back in here and I'm going to hit a magic button. And all of a sudden, we're seeing a lot more than we saw in the past. Here is the trivia question. There is a pink thing here in the Milky Way. Who can name what that is? That is a Messier object. Who can name that Messier object? Let's see who's got that. There is a delay, so that's why I'm pausing in the middle of what I'm saying. But let's see who knows what that Messier object is that was shown in the Milky Way. And because I switched back to the live chat to see who knows it, the screen is covered. But all right, let's see who can get this. That's it for those of you that are not familiar with the Milky Way or the night sky. That might be a tough one, but I'm asking it anyway. Oops. So let me look for the. All right, so the answer is correct, Tim. It is the Lagoon Nebula. Liam, you get extra credit for calling out the NGC number, although I do believe M8 is the Messier object, so I'm not sure if it also has an NGC number. Buddy, I see your chat. You don't have a way. Just try and join the Zoom. I'm on the Zoom meeting right now, buddy. Join it. I should be able to let you in, and then you can take over and go ahead and do your presentation. I'm going to go ahead and stop sharing. And we're going to get to your presentation. So, buddy, try and join. And I should be able to let you in, and then you'll be able to stream through our live stream.
The Zoom link should be in his email.
Okay, I'll post it up here too. I think I still have it. So we're gonna get it says the Zoom meeting hasn't started. What? Okay, let's do this. Yeah, the Zoom meeting should have started. Let's make sure he's got the right link. I gotta go here. Let's see. So we are fighting through our technical difficulties, and I have to figure out how much money to send Liam because he's won all the trivia things so far. Although I think Tim stole one from him with the M8. And now the next trivia question is, which planetarium is Buddy Stark from? And that we hope that we can stream here in a couple short minutes. If you can join, Buddy, see if you should be able to join. If not, we'll start everything over. There you go. And just unmute yourself when you're ready. Let's see, unmute.
Yeah, very good. Okay.
Yep, you're in. If you've got your video, you can go ahead and do that. Let me make sure that there you go. And you have to be showing Stellarium, which is what I started with.
Yeah, I saw you were.
Yep, I did. I tried to cover for you. So yeah, you should be good to go. Ladies and gentlemen from the Flint Longway Planetarium, sorry for the delay, but we have the real presenter, Jeffrey Buddy Stark. Take it away. I'm going on mute, and take your time. You've got your whole hour. Don't worry about the delay. Take as long as you need.
Okay. Let's see. I'm gonna mute that page too, because I think it's a little bit of delay and I can hear that. So thank you, everyone. Sorry for the sort of mix up. It took me a little while to figure out. I thought I was waiting on a Zoom link, and it, you know how these things go. My name is Buddy Stark. I manage, as Adrian mentioned, Longway Planetarium in Flint. And my intent today was to do just some really introductory. So if you are someone who knows a lot about the sky, or even a sort of a mid-range about viewing the night sky, then you will probably know most of what I'm going to talk about in terms of the sky itself, because normally when I do trivia things, we have some kind of, the last couple of years Astronomy at the Beach, I've brought like Xbox controllers. I made a little app for kind of like a Jeopardy competition to see who could buzz in and do it the fastest. But it's difficult to do competition style trivia on the internet. And I'm trying. Oh, there's the chat. Okay, I'm trying to make sure I can also see the chat there. So if anyone does have questions. It's going to be kind of more casual. I'm going to put one trivia question up at a time and give you a minute to try and you can answer it in the chat if you'd like to, or if you just want to answer at home, that'd be fine as well. And these are going to range from, because a lot of times we do have young children at Astronomy at the Beach, they're going to range from fairly easy questions, things that a lot of us are going to know, to some that are a little bit trickier, and some maybe you need to know a little bit of history for. And while we wait for that clock to tick down so that we aren't doing just nothing while we sit and watch this little timer go, I thought I'd talk a little bit about the night sky as well while the questions were going. So having said all of that, let's see here, getting things set. We will start with our first question, and I will start my timer here. So what is the most common type of star in the Milky Way? Let me adjust that. It looks like I've got, okay, there we go. Most common type of star in the Milky Way. In the meantime, you might have noticed, and I think Adrian already kind of drew your attention to this area here in the south right now. This particular summer, we have had Saturn and Jupiter hanging out in the southern part of the sky for really ever since the sort of the beginning of spring. And tonight specifically, we also have the moon kind of hanging out as well. And so you can see my time here is set. Or maybe you can't. It might be small on the YouTube video, but it's set for about 9:30 or so. So it'll be a little after the presentation, so you'll be able to step outside and look at. Goodness, I'm having so much trouble getting the chat to show up all the way down to the bottom there. I've got like 100 things open on my monitors to try and get this all working.
Yeah, and keep in mind, I think we've got about a 15-minute back time or delay. But
Sure.
we do have an answer. I'm about to disqualify him because he's been answering everything so far. Yeah, if you can see the chat, go ahead and take a look. But our first answer came from we call him Liam. It's William Finn, and he says that red dwarfs are the most common stars in the Milky Way.
Very good. Very good. Let's see. There we go. I had it set to top chat. Now I've got all chat. So now I can see things coming in. Very good. Yeah. So the red dwarf is the most common kind of star in the Milky Way. So let's move on to our next question. What has a gravitational pull so strong that even light can't escape it? And we will get our timer reset here. So back to the moon, Saturn, and Jupiter. The thing about the moon, if you do go outside and see it tonight, this will be, again, this is what you can expect. The thing about the moon, though, is that it is very distrustworthy. It moves very, very quickly, right? It has to orbit our entire planet once a month or so, a little faster than that, but about once a month, which means that tomorrow you can see the moon has already shifted positions. So don't expect the moon, if you go out a couple nights from now, expecting the moon to be near Saturn and Jupiter, that's not necessarily very good. William Finn, black hole. Excellent. Black hole is correct. I don't want to, part of me wants to like let the time run out and let other people guess. I don't know exactly how I want to do it. So the moon will drift away, right? So don't necessarily trust that to be there. Another thing that we're really kind of coming to the end of the season for is something that's really best viewed in the summer, but you can still see it somewhat in the fall. And let's see, we've already, black hole was the correct answer for number 2. Moving on to question number 3. If you dropped a hammer and a feather on the moon, which would hit the ground first? We'll put a minute on the clock there. Yeah, if there are any kids watching, by all means, especially, like I said, some of these, if you know it, or even if you think you got a good guess, there's no shame in being wrong, right? That's half of what science is. Really, it's 90% of what science is trying stuff. And if you're wrong, trying to learn from that and figure it out and go on. Yeah, very good, Tim. It is a bit of a tricky one. It's a little bit tougher than the other two, just a little. So the thing that's really visible best in the summer, but is also up right now, you really want to get a dark sky, which means that you really don't want the moon in the sky to see this next object that I want to talk about. So around October 6th or so, oops, I'm going to back up just a few minutes here. Around October 6th or so, if you got early enough, the moon will not be in your sky yet. Again, around 9:30 in October is fairly dark. And the brightest part of the Milky Way is up in the summertime. Let's see what our answer is here. They actually did this. Who was it? Here's a bonus trivia because I can't remember. David, what's the last name of the commander who did this on the moon? David someone or other was the astronaut that actually did this. So on Earth, if you drop a hammer and a feather, right? The hammer, of course, hits the ground first because the feather is just going to float down. But the reason that the feather floats down is not because of gravity. It's because you are surrounded by air. And that feather, being very, very light and having a pretty good surface area, pushes air out of the way very slowly. So it's got a lot of air resistance relative to its mass, and it floats down. On the moon, there is no air. So the only effect is gravity itself. So when you drop a hammer and a feather in a vacuum, they both fall at the same rate. There's a video on YouTube of, again, an astronaut back in the 1960s, or it could have been actually at that point, it would have been the 1970s, who actually did that same thing. And it turns out that, yeah, they actually hit at the same time.
I want to say Dave Collins.
Yes.
I thought he was just a pilot, but maybe it was astronaut Dave Collins.
So someone do a quick internet search. Do a Google search for Dave Collins and see if he was his Wikipedia page should say that he was the one that, if that's him. But yeah.
Bonus trivia for
exactly
you and Liam, Tim.
Yeah, expert trivia there, Liam. See if you can find that one. Okay, which planet has the most moons in the solar system? So we're talking about. I saw that one too, Tim. I actually saw the whole experiment in a vacuum chamber. That's really interesting. The Milky Way is still in the sky. The trick is you have to be somewhere really dark. Have a really good dark, clear sky. If you face the southwest, that'll be the brighter part right now. So you can see if you can't find the Milky Way. We also, okay, so another thing to talk about here, we do have Mars. Also notice that I tried to make my text in Stellarium a little bigger, so hopefully you could read that on your screen. Mars and Uranus are both over there in the east, but of course Uranus is actually not visible to the naked eye. It was there very shortly last fall. I believe it got close enough that under pristine conditions it was, but generally speaking, Uranus is not visible. So you won't actually see that. It is in that direction, but Mars is nice and bright and of course famous for being a pretty red object in the sky. Did we get anyone with this one? No, no one got this one. This one just flipped, right? If you follow astronomy news, this is a tricky one. For a very long time, it was Jupiter. Jupiter had the most moons, but they found another 20 moons that they categorized over the. Was it during this? It might have been during the summer, either the spring or the summer. And so now Saturn actually, at least for the time being, until they decide to find more, has more moons. Yeah, Jupiter is at 79, very good, and Saturn as of right now has 80 moons. So it took over here, and we're getting to the point where our telescopes and our technology are good enough that we should probably start having discussions about what counts as a moon and what is just an orbiting body, right? Because if you count all of the stuff in the rings as moons individually, then of course Saturn has lots and lots of moons. Tim's got some more information here. So maybe it's going to flip back here soon with 45 new moons discovered. If they can get some observation on those, could be very. And that's kind of what I'm talking about. Like there's going to be things that are sort of boulder size that we don't know about yet that we're going to keep finding. And so, what counts as a moon, what doesn't? That's going to be the next discussion that we have in astronomy. Well, maybe not the next one, but it's coming. How far away? How far away do you think the moon is? Now, my answer's in miles, but we'll accept it in kilometers as well. Either one is perfectly good. Let's talk about finding our bearings. You can see I've got my cheaters on here. I got these red letters up: south, southeast, southwest. And so unfortunately, nature isn't so kind. When you go outside, these aren't out there. So we probably should learn how to find the directions for ourselves as well. So we're going to start, as all astronomers do, by trying to find the North Star. Let's all learn how to find the North Star here for a moment. We're going to start by looking for the Big Dipper, which is always somewhere in the north half of the sky. I'm not going to point it out just yet. See if you can look at this sky and find the Big Dipper in that particular part of the sky. It does move around. William's got an answer: 238,900 miles. Very good. We do have, of course, with the moon, have a range of acceptable answers, right? I put 240. I'm a little less exact. Anything from about 220,000 miles to 250,000 miles is acceptable because, of course, the moon is not a consistent distance away from the Earth. Sometimes it's a little bit closer. Other times it's a little bit further away. So there is a little bit of a difference there. And that would be between 360 and I forget the other number, 420,000 kilometers, something in that range. Okay, moving on. What is the sun mostly made out of? Now I'm back to my hunt for the Big Dipper. I'm looking for the Big Dipper. If you have found it already, great. If you're still struggling, this is one of the things that you just kind of have to get good at finding because it's so helpful at pointing to so many other things. So you're looking for 7 stars. If you think you found it, count the stars, make sure that you've got 7 stars in the Big Dipper. I'll give you a hint, it's pretty low in the sky right now as well. We have H in the chat. It's a very, very cryptic answer, but correct. H. Yeah, sorry, I was going for the element. Plasma is also correct. Very good. I was going for the element that it's probably made out of.
I was just trying to be difficult because Liam got it again.
Very good, Katie. Hydrogen. Excellent. So it's mostly hydrogen. There is some helium, and of course, lots of other things as well. Carbon, neon, many other things like that. Oxygen is there. But those are all present in very, very, very small amounts. So mostly, it's made out of hydrogen. Which planets in our solar system have ring systems? Which ones? So that's a hint there. There is more than one. Which ones have rings? Yeah, there we go. Okay, so enough beating around the bush here. Let's go ahead. If you found the Big Dipper down here, then you are correct. This right here is our Big Dipper. It is, of course, part of the constellation, the much larger constellation of Ursa Major, which includes these other stars out here. But we're going to largely ignore those because for our purposes, the Big Dipper is what we want. And the reason the Big Dipper is so important, and you're going to start your stargazing with the Big Dipper, there's a couple reasons. One, it's actually always in your sky. Here in Michigan, the Big Dipper actually never leaves. So every single night of the year, if it's cloudless, that is, and trees aren't blocking your view, you can always find the Big Dipper in the north. And if you do that, then these 2 stars, ignore the handle. You don't care about the handle. These 2 stars point you to the North Star. Ignore, and you know, I'm struggling here with my mouse clicking, but you get the idea. These 2 stars point right at the North Star. That's how you find the North Star. Time is up. Let's see. I don't have any guesses yet for which planets have ring systems. Let's see what. Yes, very good, Katie. Saturn and something else. In fact, actually, all the gas giants have ring systems. Saturn's are by far the brightest and the easiest to pick out. That's why everyone talks about them. But Jupiter actually has ring systems that are fairly. Uranus, of course, is also somewhat known for its ring systems because they're pretty bright. But Neptune and Jupiter also have very faint ring systems that you can pick out in certain space telescope images and other large telescope images. Let's see, what element was discovered in the sun before it was actually discovered on the Earth? Again, this one's a little bit tougher, but there was an element that we actually didn't know about until we found it in the sun. Okay, why do we care about the North Star? Right, we found the Big Dipper, we found the North Star. First of all, notice something to really kind of drive home here. The North Star is not the brightest star in the sky. Okay, don't think, like, a lot of people think that. It's a good way to get lost, is to follow the brightest thing and think you're heading north. Don't do that. Find the Big Dipper. It'll show you where the North Star is. Why do we care about the North Star? Actually, let me leave some of this stuff up. That'll be a good way to do this. There's the North Star. There's the Big Dipper. Here's where Vega is. Here's where Capella is. And if we start fast forwarding time a little bit, we'll quickly notice, because there's other stars. This star's pretty north. I don't have to crick my neck so high to follow that star. I'm going to follow this star north, right? If we fast forward time a little bit, oh, click on the right thing, buddy. Let's see. William's giving out hints now. Starts with H. Second letter is E. Third is L. Very good. Yeah, and that is a good hint there, Tim. That the name of the element actually comes from the word sun. So helios is the Greek word for the sun. And let me get rid of that. And so we actually named helium.
Testing, testing. Can you hear me? Oh my God. Okay, I appear to be live here. Let me get this URL to my nephew. All right, so I am going to be doing a tour of the solar system here with the app called Space Engine. This is an application that is free on Windows. There's an older version that's free. The newer version is available on Steam, and I'm just going to get right into it. Continue here. Here's the solar system seen from out beyond the orbit of Neptune. So I am going to zoom into the sun here. So that is our sun, and you can see it's got some sunspots, and you'll see some granulation on the surface of the sun here. And let's zoom in a little bit more. These things on the surface of the sun here are called granules. These are about the size of the state of Texas. They completely cover the surface of the sun, and let's just go all the way in. Boom. So now we're on the surface of the sun, as it were. So let's go up a little bit. So these granules, so it's rather lumpy. So the sun is like it's boiling gas. It's almost like boiling soup. But let's go out from the sun here and go to Mercury. So this is the planet Mercury. Hold on a second. I got a message from someone. All right, so this is the planet Mercury, and you'll notice it's heavily cratered, a lot like our moon. And one of the interesting things with Mercury is it orbits so close to the sun, and it's got a very eccentric orbit. If you land on the surface of the sun, or on the surface of Mercury, and look at the sun, if I can find the sun over there. Of course, I went too far. Go back here. All right, so what happens with Mercury is pretty interesting. If you accelerate time, so there's the sunrise. I'll reverse it. And of course, it's not doing it here. I've been lucky every other. Well, there it's doing it. You can see it there. It slows down in a part of the sky. And if you're at just the right spot on Mercury, you'll see a double sunrise or a double sunset. And that's because it is so close to the sun, and its orbit is eccentric, and its orbital period is very, very short. So let's go to Venus, because Venus is a beautiful planet. And we had Venus in some of the telescopes this afternoon, which was pretty cool. So this is Venus without the clouds. Actually, let's turn the clouds back on. Yeah, it's very bright in the sky right now, and it's looking kind of like that in the sky right now. But Venus is exceedingly bright because of all the clouds. Well, we had probes orbiting Venus, and if you take the clouds away, you can see its surface is very interesting. Much craters. There's a whole bunch of active volcanoes on Venus. And these were all radar images taken from the Magellan spacecraft. The cool thing about the version of Space Engine that I'm using here is a version from Steam, and it has some downloadable content that has high resolution imagery from all of the NASA missions. So they're just beautiful. I'm upside down here. Let's go fix that. Not that there's an up in space. So this is our Earth. I'm not going to cover that very much because you pretty much know what's going on there. But the thing I will show you is the nighttime side and all of the light pollution. Norb Vance is going to be talking about light pollution tomorrow. So be sure to catch that. And let me show you something. I mean, not that I want to steal too much of his thunder, but I do want to show you one thing. So you'll notice the cities. Well, there's always it looks like a pattern there. There's Detroit, Minneapolis, but this is not a city. That is oil fracking fields in North Dakota, and that is bigger than Minneapolis. So that's pretty impressive. But I'll let Norb.
And very good, Adrian. You crushed that one. You were very quick on the draw there.
And it used to be the largest moon in the solar system until we learned better.
Yep. And it's also, if I'm not mistaken, the only moon still today that has what we would consider to be an atmosphere.
Yeah.
I mean,
And standing liquid.
You're right. Yeah.
On the surface. Yeah.
All right, let's see. What does the term dirty snowball refer to in space? Give you guys a minute to think about that.
Comment. We're just going to yell it
I'm
out.
not going to chime in. I'm not going to bother.
It's not the name of an adult cocktail.
I think it is actually.
It can be.
It is.
Are we? Should I continue without children? Are we recording this? Are we going to be posting this soon, or
We
should I
are
wait?
recording it, so keep going.
Okay.
Yep.
I wanted. If we weren't recording, I was going to wait to talk about Andromeda until we had an audience that could benefit from it.
No, keep on going.
Okay.
And
Very good.
yeah, we're first
So-
steps. We're working through it.
Yep. So Andromeda is tricky to find, and that's why we start with Pegasus, because in this area, this is one of the easier things to find. It's by no means easy, but it's kind of a stepping stone. And so we find these back legs for Pegasus, which again is actually the constellation of Andromeda. But if you'd like to think of them as his back legs, no one's going to question you on it. Okay. All right. Let's see. A dirty snowball is in fact a comet. Out there in space. We call them dirty snowballs because they're a mix of dirt and ice and other things. Let's see. What is the, oh man, I got another, I'm going through all my easy ones here. What is the name of the Lion constellation in the sky?
So for us, there's actually 2 Lion constellations.
Good point. Yeah.
That are in the sky. So
can you name the second one?
And they have Latin names. So I think we all know what they are, but all the kids that are watching this, probably post-recording, you know what the major one is. It's a zodiac sign, and we'll probably end up giving it away. There are actually 2 of them, and
yeah, you gave a hint with the word major.
Are.
You gave a hint with the word major. There's sort of okay, I won't say more. Okay.
Yeah.
So we found Pegasus. We found Andromeda. Now, the last thing that we have to do is we have to find the middle 2 stars in Andromeda. We start with the brighter of those 2, and we move towards the dimmer one, and we don't stop there. We go about the same distance again, right in this area of the sky. That's where you want to look, and that's why we started with Pegasus, because we have to kind of work our way there. This area right here is where you'll find Andromeda, and we'll zoom in here in just a moment.
Yeah, what I generally do is I tell people if you take the 2 stars in the grid square, count out 1, 2, and then count out 2 more stars, the 2 fainter. And when you hit the second one, you count up 1 and the same space up again, 2, and that'll bring you to Andromeda.
Yep, I think it's probably a similar path to what Jeff drew.
Yeah, or you can take the V in Cassiopeia and split it in half. Divide the V in Cassiopeia, divide it right down the center, through the center star, and that'll bring you in line with Andromeda as well.
Okay, hold on. I'm not sure I followed. So you want to
zoom in a little bit. No,
oh, not that one. Yeah, okay.
Yeah.
Yep, that's Cassiopeia. Go ahead, Liam.
Now, and on the right hand side, you have the perfect V. So if you divide that dead center down along the center line, through the point, that'll bring you down to Andromeda as well.
Oh, very good. Yeah. Yeah, I hadn't heard that before, but yeah, that's clever too. That might be easier actually than trying to find Pegasus and go there, because Cassiopeia is circumpolar and it is decidedly easier to find than things like Pegasus. It's easy to pick up partially because it's opposite the Big Dipper from the North Star, so you can use the Big Dipper to find Cassiopeia. That's a clever trick there. Very good. Okay.
So kids, you have 2 ways to find the Andromeda Galaxy. And if you
Yeah.
go somewhere dark, you may actually, with your eyes, with kids' eyes, you may actually see it.
That's true. You got a better
Hey,
chance
this
than we
kid's
do.
nothing. I can see Andromeda where I live on a clear night.
Really?
That-
I'm in Wixom.
Wow.
I can make it out on a clear night.
I'm in the
After
middle
you
of
get used
Flint,
to seeing it.
so
I can see Andromeda right now,
On the
actually.
screen.
Yeah, behind him.
I can too on the screen. Yeah.
No, but I can see it naked eye where I live. And even at Island Lake State Park, we can see it naked eye if it's on a really clear night.
That's nice.
Okay.
I struggle to see the Little Dipper from my backyard. So
Yeah. I see
Okay.
two stars. Oh, I can see Andromeda clear behind you. And oh, by the way, Leo Major and Leo Minor.
yes, yeah. Leo Minor is the other one. What is the largest planet in our solar system? We'll start the timer there. And now we'll zoom in and we'll actually take a look here. So this is what you would expect from something like the Hubble telescope. A small backyard telescope doesn't reveal a whole lot of detail. You will see a little bit more with a backyard telescope, but it won't reveal a whole lot of detail. But this right here is what you're looking at. One of the reasons it's one of my favorites, favorite things to try and find with your eye is because it's far and away the furthest thing you can see without the help of a telescope. It's about 2.5 million light years away. And most of the stars that you can pick out without the help of a telescope are within a few thousand light years away from you. So this is much, much further away, and it has billions and billions of stars within it. And I think the latest estimate, correct me if I'm wrong, guys, but I think the latest estimate is about 400 billion stars in the Andromeda Galaxy.
Oh, much more. It's about 160,000 light years edge to edge, and I think it's now estimated near 1 trillion. Actually.
Oh, really?
Our Milky Way, I remember when it was 100 billion, and then
Right.
200, and then 300, and now I'm even hearing 400 billion in our Milky Way. I don't know if
Oh,
that's
wow.
true, but I hear it from time to time.
Yeah, interesting, because that's news. Yeah, the last I had heard was 300 billion in the Milky Way, and I guess that would mean that the Andromeda would go up as well, because part of it was the
Yeah, I had my VR headset there doing a virtual reality flyover of Saturn. The graphics for that virtual reality flyover were made using this application. So here's Saturn, and one of the moons I really like showing people is actually orbiting within Saturn's rings, and it's called Pan. And Pan is a little flying saucer shaped moon orbiting within the ring plane of Saturn. And that is just bizarre. So yeah, there it is, right in the ring plane. It is very tiny. And I always wondered what it would be like to be standing on the edge of that. So let's find out. Doink. There I am. Oh, some clipping problems there, but yeah, that's just bizarre. So Titan is a large moon of Saturn. Uh-oh. Titan has a very thick atmosphere. I think I turned clouds off there. Let's turn the clouds back on. Doink. And they've discovered at the North Pole of Titan, there's methane lakes and probably methane rain. Titan's atmosphere is like 500 miles thick, and they landed on it when they sent the Cassini probe out to Saturn. And it took that thing a long time to drift down through that thing's atmosphere. So Titan is very far away from Saturn. Let's take you out to Pluto. I know there's a lot of debate on whether Pluto's a planet or not, but I'm not going to get into that, but it's a very cool object either way. If I could spell it right. Okay, Pluto is actually a binary planetary or object system, whatever. It has a very large moon called Charon, and they orbit around a common barycenter, which is above the surface of Pluto, so it actually wobbles when they orbit. Now I'll show you that. So that is how they orbit. But the other interesting thing, now remember how I said a lot of bodies in the solar system are tidally locked? Well, Charon is tidally locked with Pluto, and Pluto is tidally locked with Charon. So that means that they each keep the same face looking at the other one. And let's see if I can get this right here. Charon right there, so let's land right there. Doink. See if I can get Charon in the sky. There's Charon in the sky right there. All right. So because they're tidally locked, this happens. Charon will sit there in the same spot. Actually, let's turn on brightness a little bit here. So it'll hang in the same spot. And from Charon's perspective, Pluto is going to do the same thing in the sky. All right, apparently I have to get off, and there's some confusion with the streams for Longway, so I am going to get off and bid you all adieu and see if I can get on my other channel.
Off the top of their head? Maybe not.
I
Why?
would say 5.
Yeah, okay, 5. That's what I was thinking too. I know, because there's a couple other interesting one, like near it. I think is a pretty interesting moon. Okay, moving on off of my tangent there. What do we call bright streaks of light in the night sky caused by rocks and dust falling into the atmosphere? Some people call these shooting stars, but there's a more accurate term for it. And it's kind of tricky because there's 3 different words that we use, and the only difference is where they are. If they're out in space, or if they're in our atmosphere, or if they're down here already on the earth on the ground. It's the only difference. And the words are all easily confused. We don't do ourselves favors with the public when we make terms like that. Okay, let's point our small telescope first at Jupiter, because Jupiter's got some interesting things to see. I'm hoping that before I get too much, yeah, again, I don't use stellarium all too often. Okay, so I haven't zoomed in too much because this is kind of what Jupiter looks like in a small telescope. You don't really get too much of the bands across it. You might get lucky and see a couple of the larger bands. Oh, done already. Wow. All right. Okay. What do we call those? What do we call those things? We call them meteors. And this is what I mean. It's different. If they're out in space, we call them meteoroids. And if they're falling through our atmosphere and they're causing that nice, beautiful, blazing path of light, we call them meteors. And once they hit the ground, we call them meteorites. 3 different terms just based on where they're at currently.
And they usually don't make it to the ground.
Yeah. Most of them, they burn up in our atmosphere and they vaporize completely. They don't get the chance to be part of our collections. All right. Next question. What are the 2 original designs of telescopes called? One uses mirrors and the other one uses lenses. And because I didn't think about it, I put those in reverse chronological order. Lenses came first and then mirrors, but you'll have to forgive me. Okay. Now back to Jupiter. Actually, I'm going to track this just so that I don't have to worry about following it there. The great thing about Jupiter is about 400 years ago, a guy named Galileo was among the first people to point his telescope to the sky. He didn't invent it. There's actually some debate about who invented it, Hans Lippershey and another gentleman. But Galileo created his own shortly thereafter and pointed it to the sky. And one of the things he pointed at that was Jupiter. And he saw these things right here. And initially, the very first night, he thought maybe he had found some new stars. But luckily, he went out the next night and he pointed it again. And if I just jump a whole day ahead, oops, I thought I was tracking that. What happened here? Why am I not tracking Jupiter? There we go. He went out a whole day ahead and he saw that, oh, because I clicked away because I wanted that text to get out of there. He saw that the moons had changed positions very quickly. So he knew that these things weren't stars. And what he did was he made his own flip book, basically. He went out night after night and he drew the position of these things over time. And again, even with just a small telescope, because he was working with a small telescope. Back then, all telescopes were small telescopes. You can go outside, you can do the same thing. You can make your own flip book, draw. Girls. I have a couple of girls that like to fight over toys. Draw your flip book. Find the position of those moons over time, and you can watch them orbit. Just like our moon takes about a month, the furthest one there takes about a month as well. We call them reflectors and refractors. Reflectors are the ones with mirrors. They reflect light, right? That's what mirrors do. And refractors are the ones with lenses, because that's what a thick piece of glass does. It refracts light. So reflectors and reflectors.
Like.
What's that?
Liam was showing the Hubble in his image.
Oh.
And yeah, so I'm going to take a quick break to assign Hagen's meeting. So
Sure.
I'm
And if
giving you guys the actually, Tim, I'm
Actually,
making you
give
the
it to
host.
Jeff, because we have one starting at 8:15.
What about
Because
that?
our
Yeah,
event
yeah.
starts at 8:30.
All right.
So you better off
So-
make Jeff the host, make him the boss.
All right.
And
who
if
am
I run
making the
longer, you can
boss?
just let me know.
Yeah, Liam, I'll make you the boss. Or actually, Jeff, I'll make you the boss.
Okay.
That way you can keep going. Yeah, I got you at co-host. Let's see. I'll make you the host. Yes. And carry on. I'm going to go ahead and see if I can get Tom Hagen started.
Okay.
And keep doing trivia. You have the channel now because we kicked Bob off of the channel.
Okay. Okay.
And there are still
Poor
some viewers. So, all right. Yeah, we're having so much fun.
You repel
right.
the invaders.
Yeah.
Yeah, I did 30 questions. I thought that would take me about 45 minutes to get through. And maybe I just need to, I'll stop before I'm done if it takes too long. Something like
Yep.
that.
Well, yep. Carry on. I'd say it's before 8:50. It's 8:06 now, so you may have time for one or two more.
Okay. Lovely. So
Yep.
yeah, I'll stop at 8:15. Does that sound
Yeah,
good? Okay. Perfect.
that's probably good.
Okay.
So carry on.
All right. We'll do. Let's see. How long does it take light from the sun to reach the earth? We don't think about this a whole lot because here on Earth, when we flip a light switch on in our bedrooms or in our house, it seems like it's instant. Like light doesn't move, does it? It seems very instantaneous. But actually out there in space, because the distances are so big, light actually takes time from one thing to another. And the truth is that also happens in your bedroom, but it takes such a short amount of time that you can't see it happen. Okay. So how long does it take light from the sun to reach the earth? So as I was saying, you can certainly make your own flip book of Jupiter's moons. And I've lost my tracking again, but you get the idea. You can see that happening. Let's zoom out and talk about Saturn a little bit. We'll take a look at the planet Saturn as well. Let's see if I can't get tracking to work for this one. Now, again, in a small telescope, don't expect like Hubble views with small backyard telescopes, but you can, something like this is pretty typical in a 4-inch or especially a 6-inch diameter telescope. All right. How long does it take light? Very good, Katie. Nailed it. Excellent. Very, very good. 8.5 minutes. Just over 8 minutes is how long it takes the sunlight to hit the earth, which I like to explain to people. It means that if the sun were to blow up right now, and it won't, we've got a nice stable yellow dwarf star. We're right in the middle of its life cycle. It's lovely. It's not going anywhere. But if it did, we wouldn't even know about it for another 8 minutes because the light from that explosion wouldn't get here until 8 minutes later. We'd have 8 minutes of ignorant bliss. Okay. Moving on. What are the only 2 planets in the solar system that don't have any moons? Give that some thought. I think that one's doable. Just work through each planet and think about which ones have moons and which ones don't. So in your backyard telescope, you can discern the rings of Saturn. You can actually make them out. Again, Galileo also pointed his telescope at this, and when he saw Saturn, he couldn't quite see the gap in between the ring system and the planet, at least not at first. He called it a planet with ears. It kind of looked like a ball, and then it just had 2 ears on either side. Eventually, he was able to resolve that. Or it was, yeah, he was able to resolve. I was thinking of the gentleman that discovered Uranus. It was 100 years later. Herschel discovered Uranus. I was mixing those two up in my head. Okay. zooming out here. What else do we have in the night sky? Actually, we talked a little bit about Cassiopeia, and I would like to point out, let's get rid of those numbers there. Oh, do we have answers with, oh, we don't. Okay. So which two planets are the only planets in the solar system without moons? Mercury and Venus. It's actually the first two. Mercury and Venus don't have moons. It's actually, the Earth is kind of weird in the fact that it's a rocky planet with this big, massive moon. Mars has a couple moons, but they're really small compared to our moon. They're probably just captured asteroids. So very good, Katie. Yep, Mercury and Venus is the other one. Because rocky planets really don't have a whole lot of mass. So the capturing moons, like a lot of the moons out with Jupiter and Neptune and Uranus, those gas giants, a lot of those were probably captured at some point. Okay.
And Mercury doesn't even have an atmosphere.
Mercury does not have an atmosphere. There's a lot of, Mercury might be my favorite planet because there's a lot of weird stuff about Mercury. I once saw someone do a presentation where they showed what the path of the sun would look like in the sky of Mercury because its year is longer, or its day is longer than its year. Yeah, and so like the sun rises and then it kind of stops in the sky for a moment and circles back. There was like a retrograde sun for a minute, and then it continued on. It was bizarre. That is a bizarre world. Here's a tougher one. This let's see, I've got time for a couple more here. What does EVA mean for astronauts? So that's an acronym. Every one of those letters stands for something. This is something astronauts do when they're on the International Space Station. They might have to take an EVA. What does that mean? All right, give that a little bit of thought here. So we looked at, I keep clicking on my, I see everything twice and I keep clicking on the wrong one. I click on the stellarium that's not actually going to drag or move anything. Let's see here. We have, okay, so we found the Big Dipper, right? That's low in the north there, and you can see I've got a tree blocking it now. We found the North Star, and we mentioned Cassiopeia. If you want to be able to find Cassiopeia, it is also always up in the sky, and notice that it is directly opposite the North Star from the Big Dipper. You can find that sort of W shape. Also in this part of the sky, one of my girls, we adopted these dogs about a year ago, and one of them is deaf, so it's a little hard to get to her sometimes. Okay, let's see, EVA. What does EVA stand for? It stands for extravehicular activity. That's a very fancy way of saying they're going outside, right? This is when they have to go fix something on the outside of the space station or install a new module on the outside of the space station. They do an EVA. They put on their spacesuit, they leave, they tether themselves, of course, but then they hop outside, they do something outside of the actual space station itself, or other craft as well. But most of the time these days we're talking about the space station. All right, here's another. So we have narrowed it to Jupiter's moons for you, but one of Jupiter's moons is covered, and I mean covered, with active volcanoes. It actually has more volcanoes than the Earth does. Which moon is that one? Some people call it the pizza moon because it kind of looks like a little pizza with some anchovies on it. Those volcanoes are rather dark, rather sulfurous. Sulfuric is the word I'm looking for there. Okay. So that's Cassiopeia. Some other things, if you want to start practicing, the north is actually a really good place because, as I mentioned, the things in the south, like the Great Square of Pegasus, that's a fall constellation. It really only comes up, or it's best viewed in the fall season. So if you go outside right now and you wanted to find Leo, we had a question a while ago about Leo, you'd be really frustrated because right now Leo is rising at the same time the sun is. And so you just can't see it right now. You have to time it just right to see these seasonal constellations. The northern part of the sky is a little different because this section right here, apologies. Normally it's not such an issue. I'm not sure what the deal is tonight. This section right here is actually always in your sky. These constellations are up no matter when you want to see it. Okay. Which one of Jupiter's moons is covered? I'm going to check to make sure we don't have an answer. So, yes, very good. William is helping us out. It starts with the letter I and ends with the letter O. The moon is just called Io. It's just a two-letter moon, Io, the pizza moon out there in space. It's also, just like so many of these things, it's very interesting because Io is really far away from the sun, so it should be pretty cold, or at least that's what we initially would expect. But because it's kind of caught in this tug of war between Jupiter, this very massive planet, and several of the other moons as it orbits around, they kind of pull the other way. It's constantly kind of being squeezed and released and squeezed. And this internal sort of frictional forces, those pressures, cause it to have quite a bit more heat than it otherwise would. And it drives the mechanisms for those volcanoes. Okay. Last question here. What was the name of the first artificial satellite put into space? Again, we're kind of reaching into the history books with this one. Some of our younger viewers might not know this one, but it caused quite the scare for a little while here in the United States.
We'll let Tim answer that one so you can get one right answer.
Very good. It was a hint. It was put up by the Russians. So if that helps anyone, if that's a little bit of a hint there for you. We also, the last thing I'll talk about in the sky, we do also still have the summer triangle up. These three stars right here, Altair, Deneb is this one right here that Stellarium decided not to label, and Vega, this one right here, make up an asterism. It's not a constellation, but an asterism known as the summer triangle. That's over there in the west, because as we head into the fall and the winter, it's going to be setting earlier and earlier. So if you want to see that, do go outside pretty soon. That's going to be over there in the west. All right, that's going to be the time for our last question. The answer for this one, very good, kid-friendly GL. I think that's you, Tim. Is that right?
No, it wasn't me. Nope.
Oh,
Nope,
Sputnik.
got it. Yep.
Yep, Sputnik is the.
Sputnik.
Oh, yep. Skylab is a good guess too. Skylab was our first foray into space stations. So good thought there. That's a bit of history, a bit of different history there. But Sputnik was the first artificial satellite put into space by humans. Okay, thank you so much for tuning in. Again, sorry I was late there. I just was confused about sort of the process. So that's on my end. I hope you enjoyed it. I hope you had fun with a little bit of trivia. And thanks for watching.
Thanks, Jeff.
Take care.
I'm going to stop my screen share here.
And click leave for everyone.
Yeah.
And then I'm going to go ahead and end the meeting.